Okay, chapter 13, lesson 5, essential question, why is it important to measure perimeter and area? And in this lesson we're relating area and perimeter. So, our first example, the swim trophy on a table that has an area of 12 square feet. List all the possible lengths and widths of rectangles with an area of 12 square feet. The models show all of the possible rectangles. Label each model. So what they've done is all of these different shapes that they have all have 12 little units inside of them, 12 little cubes. And you can see that they have different lengths and widths. So the first thing we're going to need to do to solve this problem is count them and label them. So we've got 1 foot on this side, and this will be 12 feet. We've got one here that is 2 feet, and if I count those, that will be 6 feet. We've got 3 feet on this side by 4 feet on this side, and you can figure out those 3. They're basically just rotated of the same shapes that we've got here. So to fill in the table of the lengths, I would have one that is 1 by 12 feet, and that matches the first. I'd have one that is 2 feet by 4 feet to match this one, and one that is 3 feet by 4 feet, and that matches. And then you're going to match up these ones, which are just rotated versions of this. Because of the commutative property, we can rotate them, and you'll have the same factors in a different shape. And that is going to fill in this side of the table there. So that's how this one is done, and this is going to come into play when we're talking about finding shapes that have the same area and different perimeter, or the same perimeter and different area, which is basically what we're doing when we're talking about relating area and perimeter in this lesson. So now on the next page, an example, find the rectangle with the greatest area whose perimeter is 14 units. This is asking a different question. It has the perimeter, and we need to find the one with the greatest area. The table shows each rectangle that has a perimeter of 14 units. Complete the table. So we've got one that is 1 by 6, and when I do 6 plus 6 is 12, and 1 plus 1 is 2. 2 plus 12 is 14, so that 14 is the perimeter. 1 times 6 is 6, so the area is 6 square units. This one, 5 and 5 is 10, 2 and 2 is 4, 10 and 4 is 14 for the perimeter. We've got 2 times 5 is my dimensions. 2 times 5 is 10, which gives me the area of 10 square. And here we've got 3 and 3, which is 6, and 4 and 4, which is 8. 8 and 6 is 14, so our perimeter is still 14. We've got 3 by 4, so 3 times 4. But you'll see we'll get a different area. 3 times 4 is 12 square units. So the greatest area is 12 square units. So the rectangle with the greatest area is 3 units by 4 units, because the area is 12 square units. And obviously 12 is greater than 10 and greater than 6. So that's how we can have the shape with the same perimeter and different areas. And you'll notice as we move through the lesson, the one that has the shortest will have the greatest perimeter with the smallest area, and the shape that is the closest to a square will have the greatest area with the smallest perimeter. So that's going to be important as we move through the lessons. Now we've got number 1 that has 9 square units and 2 that has 14 square units. I'm going to let you do number 1, and I will help you with the slightly harder one, that is 14. So we've got a shape that has 14 square units, and we know that in order to find the area, we do length times width. That gives me the area. So I'm going to do numbers that give me 14. And I know one of those is going to be 1 times 14. So basically I'm finding the factors of 14. And since 14 is even, I know that 2 will be, and I can count by 2's until I get to 14. We'll count 7 times 7 will get me to 14. If I count by 3's, 3, 6, 9, 12, 15, I don't say 14, so 3 is not a factor, and neither is 4. You can try it 4, 8, 12, 16. I didn't say 14, so 4 is also not a factor of 14. But I can write out 1 times 14 and 14 times 1, because that's a commutative property, remember, of multiplication, and it just means I've rotated the shapes. So you should be able to see what the other two are here and you the factors. One's going to be that and the other is going to be the commutative property. And you can use that information to do number 1 as well. Okay, so 3 and 4 are asking the same things as 1 and 2 did. You just need to factor out these the factors that come to be 16, and that will give you all the possible dimensions of a rectangle that has this area, 14 or 20, depending on the problem. And it doesn't ask you to draw it, so you just need to get those. Now looking at 5 and 6 is a little bit different. They have the shapes given to you, and you can count or you can do the algorithms, which you can refer back to find the perimeter and the area. And once you have done that, you will notice something. You will notice some things that they have in common and a way that they are different, and that's what number 7 is asking you to do. So find what is the same about these two shapes and what is different, and that's what you're going to do on the line. Okay, number 8. Violet is making a rectangular banner for the basketball team to run through before the start of the game. 4 square feet of paper. List all the possible dimensions of rectangles with an area of 24 feet. So just like we were doing before, we are taking 24 and finding all the possible factors that I can multiply up to give me 24. I'll get you started. The first one is 1 times 24. I know 24 is even, so 2 times something will get me 20. I can count by 3's and get to 20. It's going to give me another one. And I can do count by 4's and give me all the factors, and that's what it's asking for, just the dimensions of the rectangles that are possible that all have the area of 24 square feet. So now once you've got that, you're going to use this information to find the shape with the greatest perimeter. And remember, perimeter is length plus length plus length plus length. This is not a bunch of ones. So if I'm just going to do this first one as an example for you, and that will help you be able to figure out what the one with the greatest perimeter is. So if I were doing length plus length plus length plus length, I know that on a rectangle there are two sides the same. So I'm going to have one side that has a length of 1 and another side that has a length of 1. I have one side that has, and the opposite side will also have a length of 24. So when I add all those up, I'm going to get 24 and 24 is 48, 50, so the perimeter of this shape will be 50. And see how that could be the same process on this factor pair, this factor pair. One of these will have the greatest perimeter, and that's the dimensions that you're going to write here for number 9. If a rectangle has a greater perimeter than another rectangle, does it also have a greater area? So is it necessary that just because something has a greater perimeter, does that mean it automatically have a greater area? Hopefully you can figure that out with what we've done in the things that I've talked about here so far, and that's what you're going to write on these lines here. Okay, so now looking at 11, it says, is it possible a rectangle that has an area of 24 square units and a perimeter of 24 units. Okay, so here I made just a little example of if an area has 24 square units. These are all the possible combinations for a shape with an area of 24. So if I were to redo these to find the perimeter, I would be adding them and adding another 1 and another 24, adding another 2 and another 12, adding another 3 and another 8, adding another 4 and another 6. Any of these going to add up to get me 24. Will that happen? Will that work? If it does, then you're going to say yes. Draw a rectangle that has an area of 24, a perimeter of 24 units. This cannot happen. If there's no way to get 24 when you add up all these, then you're going to say no. And I've just shown you the reason why. You need to rewatch this and write it out in your own words to get the explanation part of it. Okay, so have a difference between area and perimeter, and hopefully with what we've seen and done, you can see we've talked about this throughout the lesson, throughout chapter 13, the difference between area and perimeter. One is going around the shape and one is covering the shape. So you need to label that and put in your own words the answer for number 12. Now I've skipped over the first page of the homework because it has more examples. I'm on page 856. If you haven't spent your hour already on this lesson, then you're going to go ahead and do the homework. And it's asking the two possible rectangles for each perimeter. Find the area of each. So you're going to draw them and then find two, draw them, and then find the area of each. So when I factor out 20, I will get 1 will always be 1 times the number. And since it's even, I can do 2 times 10. And I don't have a ruler necessarily and make one that's 20 inches long because you really don't have enough room. It's just sort of representative. And you know, if you have one that's 1 and the other is 20, obviously one side is going to be much longer than the other. And you're going to have time to draw much neater. Because obviously if that is 1, that is not 1. That is not a good picture. Let me clear that and just draw a box with this. That'll help. So we're going to have one that's very narrow and very long. And if I do one that is, say, 4 times 4 is 16, it's not 24. But if I were to do one that is closer to square, I will have an answer that's closer to square. Add 2 times 10. It's going to be a little bit wider and a little bit shorter, but be very long and very narrow. So that's how we're going to draw if we had those shapes that I had 1 times 20 and 2 times 10. And you can do that for number 2 with the 8 units. Okay. Tomas drew a rectangle with an area of 6 square centimeters. What is the greatest possible perimeter for this rectangle? And I've drawn 2 possible rectangles with the area. I've got 1 and I've got 2 times 3. Those both multiply up to give me 6 square centimeters. And to find the perimeter, I'm just going to put the measurements of the opposite sides. If that side is 1, that side is 6. Or I'm sorry, if that side is 1, that side is 1. If this side is 6, that side is 6. If this side is 2, then that side is 2. If this side is 3, then that side is 3. That's one of the features of a rectangle. Now if I add these up, 6 plus 6 is 12. 13, 14. So this shape has a perimeter of 14. 3 and 3 is 6. 7, 8, 9, 10. So this has a perimeter. And it's asking you for the greatest possible perimeter. So as I talked about before, the one that is the narrowest is going to have the greatest perimeter. So the shape that is 1 by 6 will have the greatest perimeter as it's asking for in number 3. So looking at number 4, Donica has laid out floor tiles so they form a rectangle with 18 inches. It's the greatest and least possible area. Drawn out these shapes here, which have that perimeter of 18, and I just need to figure out the area of them and compare the one with the greatest area and the least. So I've got this shape that is 1 by 1, 2, 3, 4, 5, 6, 7, 8. 1 times 8. This shape is 2 by 1, 2, 3, 4, 5, 6, 7. That area is 14. This is 3 by 1, 2, 3, 4, 5, 6. Area on that is 18. This one is 4 by 5. 1, 2, 3, 4, 5. 4 times 5 is 20. So now the greatest area is 20 and the least area is 10. So I'm going to use those numbers, 20 and 8. And it's asking me in the question, it says, what is the difference between the greatest and least possible areas? So you're not writing a word answer here, you're doing difference, and difference means to, hopefully you said to your computer, subtract. Difference means subtract. So when I find that difference on this, which I'm not going to give you, you can do it. You're going to write that sentence answer here. The difference between the greatest and least possible areas is that number. So that's how you're going to do number 4. Let's move this and look at number 5. A rectangle has an area of 30 square meters and a perimeter of 34 meters. What are the dimensions of the rectangle? Okay, so we don't even need to draw the rectangles. I'm going to bring this back and show you all we have to do on this. Okay, so we know we have an area of 30. And I know that factors are going to get me to that, because to find the area I need to do length times width. So I'm going to find these two numbers, length times width, that'll get me to 30. And I know 1 times 30 will get me to 30. 30 is even, so I know that's a messy 2. 2 times 15 will get me to 30. 3 times 10 will get me to 30. And 5 times 6 will get me to 30. So those are all the factors that can get me the area of 30, which number 5 said. And now I need to find which one has, according to this, a perimeter of 34 meters. So, in order to find the perimeter, I need to do side plus side plus side. Length plus length plus length plus length. Okay, so that was just my length times width. I'm not going to worry about that one. So there will be 2 sides that are 1, and there will be 2 sides that are 30. There will be 2 sides that are 2, and there will be 2 sides that are 15. That's the property of rectangle. 2 sides that are 3 plus 2 sides that are 10. 2 sides that are 5 plus 2 sides that are 6. That's how I'm going to figure out the perimeter of each of these shapes. 30 plus 30 is 60. 1 plus 1 is 2. 60 plus 2 is 62. That's not the perimeter of 34 that the problem's asking for, so it can't be that. 15 and 15 is 30. 2 plus 2 is 4. 30 plus 4 is 34. Is that what they're asking for? Yes. So I can keep going. 10 plus 10 is 20. 3 plus 3 is 6. 20 plus 6 is 26. That doesn't work. 5 plus 5 is 10. 6 plus 6 is 12. 10 plus 12 is 22. So none of these work. The only one that works is a square with a length of 2 and a width of 15. So that's the way that you can find an area with a square area of 20, an area of 30 and a perimeter of 34. That's how you do number 5. Let's look at number 6. A square has a perimeter of 28 feet. What is its area? So the nice thing about a square is all the sides are equal. So if I know that my shape has all 4 sides equal, I can use that to figure out the area when I only have one side. So let's start with some. The property of a square is all sides are equal. And I know that my perimeter is 28. And I know that to find the perimeter, I have to do length plus length. And since in a square, all of these would be equivalent, that would be the same as doing 4 times the length. With me so far? Since all of these would be the same for a square, I can just do 4 times that number. So if I can do that, I can do 4 times something equals 28. And I can count by 4s or I can do my division. Either way, 4, 8, 12, 16, 20, 24, 28. Can't see all my fingers at the same time. 7. 4 times 7 is 28. So now I know I've got a shape that is 7 units on each side. That's not right. 1, 2, 3, 4, 5. Shoot. 6, 7. Now I'm going to do 7 times 7 to find the area. 7 times 7 is 49. So it's 49 square feet around that shape. And that's how you do number 6. Thanks for bearing with me through this long lesson. Hopefully you understand and could solve some more. I gave you the answer. Through the ones where I didn't give you the answer. Thanks for working hard, and I will do directions and be sure you're ready for the test. Don't forget to ask any questions you may have. Thanks a lot.